All right, so this is section 7.4, part 2. Okay, so if, again, we are kind of looking, excuse me, looking at some different strategies that you can use. So now, in the example below, we're actually given an equation. Okay, so now we're getting into proving identities a little bit more here. So to establish the identity listed, begin on one side of the equation and manipulate it to arrive at the other side. So you only want to work on one side. You always want to identify which side of the equal sign is more complicated and work on that side. And you keep working on that side, simplifying, combining whatever strategies that you need to do to be able to make it look like the other side. Okay, so we're going to do that for this one. So obviously the left-hand side is certainly more complicated, so we're going to work on that one. Okay, so the first thing that we're going to do, and again, notice down the right-hand side is all secant theta because we're not changing that. We're only working on the left-hand side. So the first thing we're going to do is we're going to distribute this through. So that's going to give me sine theta cotangent theta plus sine theta tangent theta. Okay. So now, very often it's advantageous to change all of your expressions to just simply sines and cosines. So we're going to do that. So we're going to have sine theta here, but we're going to change cotangent to cosine theta over sine theta. And then we're going to have sine theta over here, but we're going to change tangent theta into sine theta over cosine theta. So now if you look over here, the sine thetas cancel, so we're simply left with cosine theta. And this sine theta is over 1. If I multiply straight across, I'm going to get sine squared theta over cosine theta. So now I have still two expressions, so I'm going to combine them. So I think you can see obviously that your lowest common denominator is going to be cosine theta. So we're going to take this cosine theta and we're going to multiply it by cosine theta over cosine theta. I'm going to leave this alone. So that's going to give me cosine squared theta, cosine times cosine, plus sine squared theta. And I'm just going to do this. That whole thing is going to be over cosine theta. Well, what is cosine squared theta plus sine squared theta equal to? That's your identity. It's 1 over cosine theta. And we know because of our reciprocal product identities, 1 over cosine theta is equal to secant theta. So we've taken that left-hand side and we've shown that it is actually equal to secant theta. All right, let's do another one. Really, the only way that you are going to be able to be successful at these identities is, first of all, make sure you know your identities and just do a bunch of examples. That's really all you're going to be able to do. Just keep doing the examples. All right, so we're going to establish this identity. So we are going to, now again, we could choose to work on the right-hand side or the left-hand side. It looks to me like there's a little bit more we can do to the left-hand side, so I'm going to choose to work on the left-hand side. And I'm just going to keep working on it until it looks like the right-hand side. So I look at 1 or cosecant theta, and I'm going to make it 1 over sine theta. Cotangent theta, I'm going to make it cosine theta over sine theta. So if I were to combine those two fractions, I'm going to get 1 minus cosine theta all over sine theta. Doesn't look like the right-hand side yet. So very often when you get to a place and you think, oh my God, what do I do next? Here is a place where you want to multiply that strategy where you have to multiply top and bottom by the same trig expression. And it's usually the conjugate. So that's what I'm going to do here. I'm going to take and I'm going to multiply both top and bottom of this fraction by the conjugate of the top, which is 1 plus cosine theta. Let's see what that does for me. Well, the top gives me 1 minus cosine squared theta over sine theta times 1 plus cosine theta. Well, what is 1 minus cosine squared theta the same as? It is the same as sine squared theta I can now cancel this sine theta into one of those. And on the top, I'm left with sine theta. And on the bottom is 1 plus cosine theta. And that is exactly, if you look up at the top, what the right-hand side was. So I have shown that that identity is true by making the left-hand side look exactly the same as the right-hand side. Now, I should probably tell you now, I do not always find the quickest and easiest ways to prove identities. Proving identities is one of my favorite things to do. It's like a big puzzle. But very often students will say, well, I did that in a couple of less steps, and they show me a different way. Fantastic. So there's not just one way to do these, most of the time. All right, so the algebra is going to get a little sticky in this one. So we're going to go ahead. We're obviously going to work on the left-hand side. And we're going to make it look like the right-hand side. So the first thing that I'm going to do is I'm going to change my tangent to sine theta over cosine theta. So sine squared theta over 1 minus sine theta over cosine theta. And that's going to be over, so we're going to have to deal with all these complex fractions. Cosine squared theta over 1 minus cotangent theta is cosine theta over sine theta. All right, so I'm going to go ahead and get a common denominator on both the top and the bottom. So the common denominator is going to be cosine theta. So that's going to give me on the top cosine theta sine squared theta minus sine theta all over cosine theta over, and if I find the common denominator here, it's going to be sine theta. So I'm going to multiply top and bottom here by sine theta. So it would be sine theta cosine squared theta minus cosine theta. And that's all over sine theta. All right, so now I'm going to leave it as a complex fraction for now, but I happen to notice that on the top here I can factor out a sine theta, so I'm going to go ahead and do that. So it's going to be sine theta times, and it's going to be cosine theta sine theta minus 1, and that's still over cosine theta. Over, and in the denominator, I'm going to factor out a cosine theta from the top. So cosine theta, and that's going to leave me with sine theta cosine theta minus 1 all over sine theta. Now this is a crazy looking fraction, so what I'm going to do, and I'm going to go up here to do it, is I am going to simplify this fraction. I'm going to multiply by the reciprocal of the denominator. So let's see what that would look like. So I'm going to go up here. So it would be sine theta times cosine theta sine theta minus 1 over cosine theta times, and now I'm going to flip that bottom fraction, so it would be sine theta over, and it's going to be cosine theta times, oops, I'm going to run out of room, sine theta cosine theta minus 1. Sorry about that. So hopefully you see, first of all, that these are going to cancel. So on the top, what do I have left? I have sine squared theta over, on the bottom I get cosine squared theta. And of course, sine squared theta over cosine squared theta would be tangent squared theta, and I am done. So the algebra got a little tricky there. All right, so that's the end of the notes for 7.4. Have fun with those proofs.